Okay, let's wrap up this question. So here's what we have going on. We have two equations, and so you could call those a system of equations, right? We have two equations and two unknowns. And so that's how we know that we can solve this. If we had more than two unknowns, but only two equations, then we wouldn't be able to solve for that. Okay, so however many unknowns we have, we need at least that many equations to be working with. Now, typically, I'm working more towards this side because if I lay this out more, this is the same thing. T1, let me draw a line so you can, oops. Okay, T1 in the y direction, that's the same thing as T1 sine of 30 degrees. Okay, plus T2, which is T2 sine of 60 degrees. Okay, that's going to equal 30 newtons. So what you do with a system of equations is you solve for one of those unknowns and then you plug that in to the other one. So there's multiple ways you can go back and forth with doing this. I suggest using this more simple equation to solve for that unknown. So like if I'm looking here and I want to solve for T1, well, all I would do is divide by cosine 30. So T1 would equal T2 cosine 60 divided by cosine 30. Okay? And now I'm going to see this all equals T1. I'm going to take this whole thing and I'm going to plug that in for T1. Okay? So that all equals T1 and I'm going to plug that in right there. So I'm going to say T2 cosine 60 divided by cosine 30 plus T2 sine 60 is equal to 30 newtons. Okay? Oh, I forgot, because I replaced T1, but there's also, right here, there's still a sine 30, right? So let me rewrite this again. I'm going to pull out that T2. So I'm going to say T2 multiplied by cosine 60, and then we have that sine of 30 as well. Sine 30 divided by cosine 30 plus T2 sine 60, that's going to equal 30 newtons. Okay? So now all we have to do is factor out T2. Okay? And it's simple factoring. We just pull out T2 and we say T2 is equal to cosine 60 sine 30 divided by cosine 30 plus sine 60. That's going to equal 30 newtons. Okay. Okay. Now, I can plug it into my calculator just like this. I can do 30 divided by all of that. But there is a way to simplify this a little bit. Sine of 30 over cosine of 30. Sine over cosine of the same angle is tangent. So I could write this as T2 cosine 60 tangent 30 plus sine 60 equals 30 newtons. Okay. So T2 is going to equal 30 newtons divided by cosine 60 tangent 30 plus sine 60. Okay, let's plug it in our calculator. So on the top of our fraction, we have 30 newtons, and we're going to divide that by everything on the bottom of our fraction, which is the cosine of 60 multiplied by the tangent of 30. Okay. Now if we want to, we can put a parentheses around this thing, multiply those together first, but your calculator should automatically do that. Plus the sine of 60, and then close the bottom of that fraction. So when we look on our pretty print here, we see we got 30 divided by 60, cosine 60 multiplied by tan 30 plus sine 60. That's exactly how we have it written down. And that gives us 25.98. We've been working with 2 sig figs mostly. Kind of drop the decimals here. So that'll be 26. So T2 equals 26 newtons. Okay. T2. And then we have this equation right here of T1 is equal to T2 cosine 60 divided by cosine 30. So how about I take my T2 and I plug it in right there. Okay? So T1 is equal to 26 newtons cosine 60 divided by cosine 30. Okay. So I'm going to take that 26 times by cosine 60 divided by cosine 30, and that gives me 15 newtons. Okay, so we solved for our unknowns. We found T1 and T2 by looking at the sum of our forces, getting 2 sets of equations, solving for one unknown, plugging that in to the second equation to solve for our second unknown. And then once we knew what T2 was, then we could plug that back into this equation to solve for T1. Okay, where are we time? All right, so that's example number 4. Okay. So what does equilibrium mean when applied to an object? So take a moment, hit pause, answer these questions, and then come back and play the videos, and let's talk through that, okay? What does equilibrium mean when applied to an object? Equilibrium means that the sum of the forces are equal to 0. How do the forces in static problems differ from the forces in dynamic problems? Simply that for static, the sum of the forces equals 0, but for dynamic, the sum of the forces do not equal 0, which means that there is some acceleration. How can an object in static equilibrium be in motion? Well, if it's static, that means sum of the forces is 0. And if we have a constant velocity, that means the acceleration is 0, and so the sum of the forces would be 0. What must be true about the net force of an object whose velocity is increasing? Net force of an object whose velocity is increasing. So if we have an increase in velocity over time, that would mean that we have a positive acceleration. So what's true about the net force? Well, the net force isn't going to be 0, and it's going to be some positive force. Okay, so the net force is not going to equal 0, but the net force is going to be some positive number because the acceleration is some positive number. Okay. Describe how you would determine the sum of the forces acting on an object in 2 dimensions. Okay, 2 dimensions. So we're talking about our x component and our y component. So the way that I would determine the sum of the forces, well, I would do the sum of the forces in the x direction and then the sum of the forces in the y direction. And then I'd use Pythagorean theorem to say the overall sum of the force will be sum of the forces in the x squared plus sum of the forces in the y squared. Okay. Our next day of class, we're going to be looking at learning target number 4.